many threats in the coastal aquifer. So that's why I suggest these sessions, and thanks for being here. And the first presenter, and also every presentation has 20 minutes. I will give you alarms in such a way to notice you at 15 minutes. Okay, and okay, the first presenter will present about the MAR on the island of Gotland, Sweden, exploring the potential and feasibility in comparison to alternative measures. There are two presenters, Dahlqvist, Peter, and Shortstrand, Karin.
Yes.
Please welcome.
Thank you. I don't know. Yeah. Do you hear me? Yes, you're getting two presenters this morning. I'm from RISE, Research Institutes of Sweden, and Peter is from the Geological Survey of Sweden. And we're going to present parts of a project where we have analyzed and compared a lot of different or alternative solutions to improve the water availability on the island of Gotland in Sweden, and managed aquifer recharge is one of those solutions. So I'm going to start to give you some background information about the project. Generally, we have good access to natural water resources in Sweden to support the water supply. However, both the water availability and the water usage vary largely across the country, and particularly the southern and the central and the coastal areas can experience water shortage during the summers. And one of the most water-stressed parts of Sweden is the island of Gotland, the one in the square here. It's Sweden's largest island, about 3,000 square kilometers. It's located about 100 kilometers from the mainland in the Baltic Sea. It's about 58,000 year-round inhabitants on the island, which it should be compared to the vast number of visitors, which some years can exceed 2 million. And the peak season of the tourism is during the summer, resulting in a large seasonal variation in the water demand, and with the largest demand, or the highest demand, occurring when the water supplies are at their lowest. And this, in combination with the fact that the island has very thin soil layers, it has a limited reservoir capacity in the limestone bedrock, and there's an extensive drainage of the arable land. It results in a high precipitation runoff and difficulties to uphold the water supply to society. And in addition to this already constrained water supply situation, the total water demand on the island is estimated to increase with about 40% to the year 2045. So the project we're going to present today is a study of alternative solutions to increase the water availability on the island. And MAR is one of those solutions. So Peter is going to present the mapping of potential areas on Gotland for MAR, and I'm then thereafter going to present some of the results from the comparative study.
Okay, so the material we used for the mapping was the digital elevation model, which we now have for all Europe, perhaps, but it's really good. Then we have the bedrock surface. We have the surface waters, geological 3D model, the annual natural groundwater recharge, which differs on different parts of the island, but quite low, 200 to 260 millimeters per year. And we have the storage capacity combined soil and bedrock. And as you can see, this map here is the soil, the storage capacity, and as you can see, it's very limited capacity. This is also in millimeters, so we don't have much capacity either in the soil and the bed or the bedrock. The method was a ArcGIS method, and first we calculated the ratio between the groundwater recharge and the storage capacity, and we used these areas with the numbers below 1 because they had larger storage capacity than the natural groundwater recharge. Then we located areas for infiltration with a 3D model. First we took the areas with the thickness of sand gravel deposits was above 4 meters, where being very good for this island, where we could infiltrate water. And then we used also the 3D model to this one to locate laterally restricted depressions in the bedrock, where the water has harder to disappear or flow away. Sorry, I forgot to mention the blue areas in this map is the thick sand and gravel deposits. And then we looked at the proximity. We need a source, and we had this the rivers, streams, and lakes here. And we used 200 meters on the small waters and 500 meters on the larger ones as a buffer zone. And then we used the geological model to pick out areas, the brown or color here, the areas with where clay and till is above 4 meters thick. And the results, we got some suitability for the infiltration and groundwater storage. And these are the best areas, the dark blue, the most suitable, and then second best and third best in the other ones. The areas with proximity to the water source and conditions for storage in man-made dams was found in a total area of approximately 10,000 hectares. And the combination, we found that at least 8,500 hectares have probably good local conditions with both infiltration and local depressions, and also close to surface water and or areas with thick clay and till where we could use where we can build dams. And then I leave for Karin.
Yes, so now we know a little bit about the possible areas of where MAR has potentials on the island of Gotland. But there are many alternative solutions that also could be used to improve the water availability. And in order to make sound prioritizations on which measures to further investigate or invest in already, we made a comparative analysis of 16 alternative measures. And we've done that by a financial cost-benefit analysis over the time period 2019 to 2045, in which the measures then were ranked to get a quantitative visualization of the results They were then displayed in a marginal abatement cost curve. So as I said, MAR was one of the alternative solutions in this comparative study, but we didn't use all the sites that Peter just presented in this study because we didn't have all the data for all the sites. So we looked at the MAR sites, the green ones on this map, where the municipality already have existing well fields and waterworks, so the MAR could be used to just strengthen the already or the current raw water resource, the groundwater there. So, as I said, there's many different solutions to improve the water availability. Could work with decreasing the demand or increasing the supply. And in this study, we had a large multidisciplinary stakeholder workshop with stakeholders from all over the island to select which measures they were interested in comparing. And this is the list that we then analyzed and which the stakeholders themselves thought the measures were interesting for one reason or another. So without going into the details of the calculations, this is the marginal abatement cost curve for the analyzed measures for the island of Gotland, grouped in agriculture measures, household measures, industrial and municipal measures. And each measure is here a bar, and the height of the bar represent the cost of water added or conserved, and it's expressed in Swedish kronor per cubic meter, and a euro is about 10 Swedish kronor. And the width of the bars are the annual water added or conserved by the measure. And as you can see, agriculture measure like sub-irrigation or increased sub-irrigation in irrigation dams, together with some of the maybe more traditional municipal measures like increased groundwater extraction, were some of the most cost-effective measures on Gotland. The household measures all came out as the least cost-effective. And of the municipal measures, groundwater extraction and desalination had the largest potential, but desalination on the island was about 25 times less cost-effective, partly due to the long pipelines needed to reach demand centers. And MAR here had about the same marginal costs as increasing subsurface, surface water extraction on the island. And the potential, as I said, we didn't analyze all the MAR sites that Peter presented. So the potential of MAR will definitely increase when we also include the other sites who weren't included here. And this is actually almost the same result, but here we also show the uncertainties associated with the marginal costs, displayed as the 50th and 95th percentiles. And to conclude, as I said, the MAR on Gotland didn't have the largest potential, but we didn't also include all the sites that we now know more about. But using the visualization in the marginal abatement cost curve helped the municipalities and the stakeholders to get a common framework and to discuss and to prioritize which measures to further investigate. So it was helpful in the discussions with the municipalities and the other stakeholders. And for future work, the storage capacity mappers that Peter presented will during this fall be updated. It's currently on the national scale for Sweden, and will be more detailed on a regional scale in the fall. And we're also working with the municipality for an online planning tool to help them where a geological model of the island can be combined with measure-specific models to kind of look which areas to exploit or which areas should maybe not be exploited because of their importance to water supply. And we're going to look at some of the municipal measures that had in the comparative study to see how they can, their potentials to reduce risk of water shortage in the future, and also add some environmental, or include the environmental benefits of some of the measures. All right.
Time for a couple of questions, please.
Thank you for your interesting talk. So can you go back to the result sections? Okay. That's fine. So I understand that you categorize water alternatives of different types of alternatives into four. I mean, agriculture, households, industry, municipality. So just wondering that how you categorize the four, how you categorize the water alternatives into four, because so far I understand that households and municipality may be stakeholders and agriculture industry may be a purpose. So under what, how you, on what basis you categorize all the alternatives into four, whether it's based on purpose of the water usage or the stakeholders, those who are responsible for implementation. Thank you.
Yeah. They will also be categorized for the purpose of the water, but it's not presented here. So the households, for example, it's not the domestic use of municipal water supply. It's a large part of the island are using their own wells, for example. So this is the household measures, for example, is whenever a single household. So that's how that was categorized. And the municipal, some of those measures can definitely be made even by the industry, like MAR could also be made by industry. But here we counted with the municipal numbers or calculations of investment costs, for example, and operating costs, if they would do that, and if they would incorporate the water into their water supply system. So that's why they were categorized like that.
There is still a question of uniformity just with regards to categorizations of 16 or something like this water alternatives into the four. So is there still question about the uniformity with regards to categorization of all the alternatives into four? It's municipality, households, maybe households alternatives, maybe it's a community or that state or municipality, something like this. But purpose, agriculture may be a good purpose, industrial purpose, maybe drinking purpose.
Yep.
So I am still just doubt about how you just categorize all the alternatives into four.
Well, in this one, it's actually who's also would be financing the measure. The measure here with the household measure would be financed by the households themselves. So it's also part of the financing of the measure. Yeah.
Okay, thank you for hearing, Karin.